Awesome. Thank you. Okay. So welcome everybody to this KodeKloud CKAD study session. We are today in the 6th session, and we've been conducting this already for like several weeks. And we've been talking about several topics to help you guys to ace this certification. But before we go into the topic, let me introduce myself. My name is Paco Bernabé. I've been working for already almost 20 years in in all kind of infrastructures. I started as a Linux administrator, and now I'm specialized in cloud infrastructure and DevOps. In the last years, as you can see on the right side of the screen, I've been doing some certifications. Of course, some of them about Kubernetes. And well, for me, the next step is now that I've been doing the certification is to teach more people about them and help more people to pass the certifications. Just let me show you the agenda. Today is the 12th of July, and as you can see from the first to the 5th session, we've been doing, we were talking about several topics around the CKAD, and today we're going to talk about multi-containers, pods, init containers, jobs, and cron jobs. And as always, because this is not a presentation, I always do everything via the command line. Let me go to my terminal, and I think we can start. Look, many times you will see that pods have only one container. This is, well, the majority of the times you will see only one container, but sometimes, for whatever reason, you might need a sidecar container, right? And I've showed you in the other sessions how to create pods, and if you haven't seen it, you can see it in the recording. I like to do this from the command line. So, for example, if I would like to create a pod, I do it like this, and let's call it colors. For example, we need an image, and we can call Nginx Alpine, for example. Doesn't matter, a small one. And what we are going to do here is, if I run this, of course, I will get a pod with one container called colors, but I want to get a pod with several containers. So the best way for me to do this is to do a dry run, as I showed you many times. I export it as a YAML, and I can export it to a colors.yaml file, right? So you will see that there's no, oh, sorry, this is from before, sorry, I need to delete it. But if you run this, you don't run the pod, but you export what you have here as a YAML output to this to this file. So now we can inspect the colors.yaml file, and you can see here, of course, you have the pod. The name of the pod is colors, and you have a container called colors as well. So by default, it takes the name of the pod. But let's delete things that we don't need, like this. And we can call this one yellow, for example. And we can create another container with the same image, just for the example, right? And we'll call it red. And what I want to do here, so that you can see that we are creating a pod with two containers, and we can get the logs afterwards from both containers and the pod itself. So what I want to do now is to run a command, as I showed you in the previous sessions. We can do it with echo, and then we'll say this container is yellow, and we will do the same for the other container. We'll do the command, and we'll do an echo from a string. this container is red. And you know what? Most probably this won't run, it will complete. But what we want to see is the logs from both containers. So you can have the logs from the pods, from the pod and both the containers. So now that we have the manifest, we can apply whatever we have in this file. As you can see, it already completed. It's not running anymore, but we can get kubectl logs from colors, and you know it. You will always have how do you call it, a default container. In this case, is yellow, and it took red as the sidecar one, right? So it's gonna show this as the logs. But if you want to see the logs of both containers, you can do logs colors, and with the option minc, you can select one of the containers. In this case, we select yellow, and the output is this container is yellow, but you can select also the other one and say the container is red. So this is a way how you can create a pod with several containers, and you can have 2, 3, 4, doesn't matter. The important thing is that you do it with a dry run, so that you can add the second container, and if you want, also to change the name of the first container, because as I told you, the name takes the name of the pod, but if you want to change it, you can export it to a file and make all the changes. As I explained you also in the first session, don't try to do this from scratch. Always try to create at least a skeleton, and from there you can start working. Let me see if I miss anything here. No. Okay, so now we can go to the next one about init containers. Init container is it's an extra container that you can put in your pod, but where you don't want to, what you want to do in the init container, you don't want it to be part of your application. So something that you need to do before your application is running, like I don't know, if you want to call sleep for whatever seconds, you can do it. If you need to create a user, or you need to create a certain file, or you need to create a directory, whatever that you don't want to be in the application itself, you can do it in the init container. As I explained you also in the first session, and if you didn't, you can see it in the recording. I like to do that also because you need another variable. You cannot put it in containers. You need inside the spec, you need the init containers, and the way how you can find it, at least how I like it, is by using the kubectl explain, because you can say pod spec, and you have a lot of variables, and you can make it easier if you do it with a grep, right? You can do it grep init, and look at this. So now inside the spec you have containers, of course, and you can put also init containers, right? So this is what I explained you about init containers. Something that you need to initialize before your application is running. And the same as containers, init containers admit a list of containers specifications, right? So if you copy this, we can do the same now, and we can do another one: kubectl run mypod. Let's put the same image, nginx alpine, and or we can put a version if you want. Let's do 126, for example. Doesn't matter. And let's do a dry run, because we need to complete the manifest in this case. We'll do YAML and then mypod.yaml. If you get the pods, you see this pod is not running. Let's delete the previous one. We don't need it anymore. Okay. Let's check my pod.yaml, and let's see what we have here. So we have, we can delete this, we don't need it. Oh, we do need this, hold on, sorry. Let me go back. Let's delete everything we don't need so far. And we can put here, as I showed you in the explain, inside the spec, we have also init containers. So let's add it here, init containers. And we can put the same. So we can select an image. We can also select the same one, Nginx 126. We can give it a name, my init pod or my init container better. And actually you can change the name this one, look. My container and my init container, right? And what we can do here, we can run something so that we can see that the container here won't start running until this one is finished. So whatever you do here, it will happen before this container is even starting. So if we have a command, for example, normally you do that, we can do a sleep 20. Remember that, oh, sorry. The number needs to be between double brackets, right? So it doesn't take the number, but the string. Double quote, sorry. So like that, we have it like this. We already did the manifest. As you see, I didn't start from scratch. I got the skeleton, and from there I start filling it out. kubectl apply my pod.yaml. So I create my pod here. And look what happened. Describe pod, my pod. Let me go first here because I want to do describe before the init container finishes. So as you can see, when we get the pods now, you don't have it running yet, right? It says here that the init container is still running, right? And if you describe it, you can see both containers. The init container with the status running, and the second container, or the container that is part of the application, is still waiting, right? So it says, look, until the init container is not finished, I cannot start running, right? If we run it again, now that we put the sleep 20, now you can see that the pod is already running. The init container is completed, and my pod with one container, look at this, the init container doesn't count as a container of the pod or the application, because it completed, so only the container counts as part of the pod. And if you describe it again, you can see that the init container here, the state is terminated completed. So it ran the sleep for 20 seconds, and once the command is done, it says, okay, I'm completed, and now my container can start running. You can put, if you want, several init containers. And let me show you that also. Let's delete again pod, my pod. Force, and let's check again the manifest, and we can add another one if you want, because I want to show you that the init containers, they don't run in parallel, but they run sequentially. So we can put another one, Nginx 126, sorry, 126, name my other init container, and we'll put command, this time sleep for, let's put 5 seconds, for example. So now what we will have is that this container will run for 20 seconds, and this one for 5. And then Once both are finished, first this one, then this one, the container will start. Let's make sure that nothing is running. Apply minf my pod.yaml, kuctl get pod. Now you have here 2 as init, and then kuctl describe pod my pod. Look at this. Now the first one is, let me see what it is, here. The first one is running, and the second one is not doing anything so far. It's still waiting, right? So the second init container and the container of the application both are waiting until this one is finished. If we do it again, let's see what happens. So now you can see that before, now this one is completed, then this one run and it's also completed, and my container of the pod is running. Right. So remember that all the init containers, they run sequentially. Let me show you the other way. The sleepy hitman. I like to do it. No, you cannot do it because what happens here. Let me show you in the pod. You have 2 ways of doing the command. Either like this, or let me show you the other way. You can do it also like this. And maybe like this is more clear. There are 2 ways of when you have a list, because command accept a list of arguments, and with a list you can put it in both ways. Let me save here. So either you do it like this in one line, or you do it in several lines, and every line you put one of the arguments, right? So every argument, let's say, this is a command, this is the first argument for the command, but this will be a member of an argument of the list, right? So you cannot put the sleep 20 all together. Is it clear? Any questions so far? Well, Seven, if you have database in Kubernetes, it could be one of the use case. I never tried to do a database schema from a container, but you can try it. And another use case for init containers, as I told you, if you need to create a directory or create a file, create a user inside the container, whatever thing that the application can use in the other container. These are normally the use cases. Anything that needs to be there before the application is running. And you don't want this to be part of the application, let's say. That's why you use init containers in this case. Okay. For the next one, let me go. I created. Let me see if I still have time. Yeah, I still have time. What I want to explain you now is about jobs and cron jobs. Yeah, normally jobs you do them if you need to. If you need a pod that need to run a task several times, right? And you want to run the job for several times until it succeeds. And I can show you here how to do it. So I'm going from a pod that I got from KodeKloud, but I can show you this one. If let's explore this one first. And actually this image you can download it from the repository of KodeKloud. That's okay. Or you can build your own image, right? But this one, basically what it does it shows a random number between 1 and 6, and it succeeds if the number is 6, and it fails if the number is between 1 and 5. So what we can do, let's make sure that nothing is running. We can run this this pod. It's creating. Let's wait. Error. And now we can look at the logs. Logs through dice. So you can see it's 5. You know. And what we can do is delete and recreate the pod. Delete and recreate the pod. But that's why you have jobs. You can tell a job how many times you want to run this pod until you get until it fails many times, or until you get a job or a pod that succeeds, right? And the way I like to do this one of the ways I explained to you is by using the help, right? And first let's delete this pod. I'll show you. Well, sorry, delete. I was getting delete pod. Okay. Now we don't have any theme. To create a job, the way I like it is with the help. QCTL create job. So you have, of course, all the fields that you can use, all the parameters. But where it is important, that normally what you need is this in here, right? So you have already the line here. That's everything basically that you need. So we can create the how do you call that, the job, name job, and we can call it throw dice job. We can select an image. In this case, we can use the same image. Let me see, what was the name again? Let me see. Hold on. Let me open the image. We'll use this one. And let's create the job. QCTL, create job, and we'll give it a name. Throw job, throw dice, job, min image, and we can use this one. And what we are going to do now is we don't want the how do you call it? What we want to do is to do a dry run and complete from there. Dry run client, min or YAML, and we'll put it through dice job.yaml. Okay. As you can see, there are no jobs running. So let's open the file. Throw dice job.yaml. And look what we have here. What we have here now, and you have to be really careful with this. We have a job now here, and you can see the spec accepts a template. And the template is to add a pod. Okay. So what we did now, we are creating a job that is going to run this pod for several times, right? So we can say it, we want these jobs to run for 6 times, or we want the job to run until it completes, or we have a successful pod, right? And it is very important to know the parameters that we need to put here, because now, if you see here, we can add more parameters here. right? Let's go back to this one and let me show you what we have. The important ones, of course, right? Because you have many, but with kubectl explain, I can show you the ones that we need. kubectl explain job spec. Let's go from the beginning, and I want to show you 3 of them, at least. The first one is back of limit, and of course, you don't want a job to be running forever, right? So you can tell, like, okay, at least I'm gonna try like this many times, and if it didn't succeed, then stop it, right? And you don't need to put it because the default, if you don't say anything, the default is gonna be 6, right? But you can specify, you want to give it more time or more chances. You can put it in the number you want. The second one that I want to show you is completions. This one here. So in this case, if you set this, you are telling the job, I want the job to run until that many pods succeeded. And you can put it in 1, 2, 3, whatever. But if you do that, remember that the backoff limit needs to be higher, right? Because there is a chance that the job failed, right? So if you put completions in 20 and you put backoff limit in 10, then you will never reach this 20, right? Because there is a chance that it will fail much more times that you completed the job. And the third one, because sometimes, of course, you're running the job and you put a high number of completions, you can do it in parallel. By default, you will run one at a time. But if you want to create 2, 3, 4 pods to get faster to the completions, you can do it with the parallelism. So let's do it all of them at the same time. Let's put backoff limit, for example. Let's put a backoff limit of 20, for example, right? We can put, and as you can see, I'm not remembering anything, I'm just copy pasting, right? As I told you many times, don't try to remember, to memorize anything. Let's put completion at 3. And then, and then parallelism, this one especially, I always forget how to write it. So nice that you can copy paste. We can do it, for example, in 2, right? So what we are telling now, our job is that we have at least like max 20 chances, right, of a limit. We need 3 completions. So we want the job to be successful 3 times, and we are going to run it 2 by 2. So now we are going to create every time 2 pods all the time, right? Not 1 by 1, but 2 by 2. So now, as you can see, from the command line, I created this skeleton, and I could complete everything I needed. And as you can see, remember these parameters, they belong to the spec of the job, right? So we go out, and nothing is running. So let's do kubectl apply minf throw dice job. Jobs. As you can see, now the job is running, and we have 0 out of 3 completions. But what we can do now is watch the pods that we are getting created. So look, we have now 2 with error, and 1 is completed. I hope there will be more created. Now look, remember the parallelism? There are 2 now running and completed. So it was faster than I thought, but now it went really fast. So it created in total 5 pods. So under the 20 that we put in the backoff limit, it was creating 2 by 2, and we get 3 completed, right? So jobs, why are they useful? Well, if you need something to be done several times by the same pod, some tasks, jobs are really useful, right? And you can play with jobs as much as you want, right? You can. Why the other two jobs have? Okay, let me finish and I'll tell you. So if you need to run tasks several times, jobs are really useful. So, and answering to your question, good Hydra. Let me show you. So the image that I got, if you check in the log, let's show this one, for example. This image, what it does is creates a number or shows a numbers between 1 and 6. If it's between 1 and 5, it will give an error. And if it's 6, it will be completed. So you can see, I selected the first pod and it's 5. But if I select this one, for example, it shows 6. So meaning is a successful pod as part of the job. So the same will happen with this one. Let me see what number showed this one. 4 in this case, and this 3 shows 6, right? So I told the job that they wanted 3 completions, and there are 2 pods running at the same time to do it faster. I could put even more, and it would get even faster, or 1 only, and it would go slower. But you can choose. But the important thing is that see if I can open this again. The important thing is that you know about these three parameters, right? That you know where to put them and you know what they are for, because basically this everything you need to do the exercise in when you need to do it. They might ask you for one of two of the parameters. So Leke, this means that if we only had 2 completions, the job will continue to run till it reaches the max count on 20. And if the completions complete 3 before getting to 20, it will stop. Yes, that's exactly correct. So everything that you are saying is correct there. You will reach, so the job will finish if it reaches one or the other number. So if you have, if you go until 20 and you go to completions, that's the thing, that's the limit, because you don't want the job to run forever, right? And the other way around, you saw here. Let me get out. You saw here that we ran 5 pods and 3 were completed, and that's under 20. So it's always one or the other. Okay, let me, while I see somebody's typing a question. So this is with jobs, but why the back policy is never? Oh, this is the restart policy, but this is about something else. It is in never because when you have a job normally, if it failed, you don't want the pod to restart. Yeah, but you could put always, and it will restart. It will restart the job, right? The pod. But for jobs, you want to create new pods in this case, right? Because otherwise, it will start creating. It will start creating pods indefinitely, and that doesn't make any sense. For a normal pod, you can put always if you want, but inside a job, it makes sense if you put never. Is this what you were asking? Okay, in the meanwhile, let me go. If we never restart the container, the back of limit will increase. No, I mean the container is in error, so you don't start it, and the back of limit what we put is 20. So as you saw, the two containers that failed, the two pods that failed, they stayed in error and they didn't restart. So the back of limit is still in 20, and we have we completed we ran 5 pods, 3 completed. So that's the back of limit is still there. Okay, let me go because I have here 9 minutes. I hope we have time. Otherwise, we can restart the game. Let me go to the last topic of today about cron jobs, because normally, of course, you can run a job from the command line like I did, but sometimes you want to schedule that, right? So, for example, and we will create it the same way, right? So we can do kubectl create cron job. Same thing with this. Look at this. kubectl cron job. And again, as I told you, always from the command line, we can do kubectl create cron job. Let's call it throw dice cron job mini image. I have to let me open the game. Let's copy this. Let's kubectl create cron job throw dice cron job. Again, let's do a dry run. I want to show you how it goes. Dry run client min o YAML, and we'll export it to a YAML file. Oh, sorry. I need to put the schedule, of course. It's let's put the schedule, because this is how you wanna the schedule one is gonna tell you, or it's gonna tell the cron job how many times it needs to run or when it needs to run. And actually, I can copy this one, right? Doesn't really matter, just as an example. So basically, it's gonna run every 5 minutes. And what? Did I put the image? I didn't put the image. And this is what I told you have to read carefully, and I'm not doing it today. Let's put the same. We said, sorry guys. Let me let's do one thing. I need to copy the image again. KodeKloud throw dice. Apologies for this. Let's start from scratch. kubectl create cron job throw dice cron job. The name and now the name of the image. Again, the schedule, we can copy it from here. And let's copy the rest of the line. So now we have the name of the cron job, the image, schedule. We are doing a dry run, and we are exporting it to a YAML file. Throw dice cron job YAML file. Okay, look at this. It's important to know what we are having here, because now we have 3 levels of specs, right? Now we have the spec for the cron job, which the spec for the cron job, and now it emits a template for the job here, and the job admits a template for the pod, right? So now we have, and at the same level you have the schedule. So every 5 minutes, this job with this pod is going to run. And as I told you, the pod it keeps shows a number between 1 and 6. 1 and 5 it will fail. 6 it will complete. Let me see how much time we have. Okay, we still have time. But remember that we had these three things from the job, and I want to show you where you need to put it here, because now you have 3 levels. Let's copy this, and let me show you in the cron job. So now, because this part is the spec for the how do you call it, for the cron job, you need to put it here in the one for the job. Sorry. Oh, sorry guys, I need to put it again. Let me copy it correctly. Like this. Okay, so now we have everything. Let me delete first the job that we ran before. Throw this job, okay. And as you can see, we don't have pods. We don't have jobs. We don't have any jobs. And we have the cron job. That is cron job. You can see we have the limits, everything, back of limit completions and parallelism for the job, and the schedule for the cron job. So if we now apply row dice cron job to CTL get cron jobs, you can see here that we have this cron job, right? It is scheduled for every 5 minutes. Let's see if it's creating the job. But there are no jobs. Well, it will create it afterwards. But you can put any number here. If you're having difficulties with normal cron job, then I would recommend you to go to any Linux page to understand how these numbers work. But you can put every 5 minutes or any other time. You can specify a time in the day for your job to run, right? And just to finish that, to tell you that well, you have the 3 levels, right? You can have a pod that runs a command. You can have a job that run the pod with the command, so that you can have several completions if you want, or you can run this command in parallel with several pods at the same time. And if you want to schedule that job at so many times in the day, or a certain time during the day or the week or the month, you can do it with the cron job. Just remember that you have the 3 levels, and you need to be really careful where you put everything, right? Of course, to me it really helps to create these objects or these resources from the command line, and it really helps the explain the explain command, right? So as I showed you, for jobs you have all this parallelism and completions and back of limit, but you can do the same thing for cron jobs, right? You do you explain cron job spec. You have the 2 important ones for me, actually, because they are both the ones required, right? You have the job template, where you saw that you could add a template for the job, but if you do it for the command line, you will have it directly, and the schedule you can add it also from the command line. So those are the 2 important for the cron job. So I think we are now 45 minutes in the session. Do you guys have any question? To see if it's run, of course, yeah. Let me see. Actually, we can see, I don't know if now let me see if we have more time now. Oh, no, let me create another one. Yeah, let's do it again. Let me copy it. Let me see. Let's do it again. Actually, you can, no, we don't need this. We can do it like this. kubectl create cron job min age. Let's do it like this. My cron job image, and this was KodeKloud. Actually, we'll create everything from scratch. KodeKloud, and then schedule. Let me see how many we have. Let me see. Try run client or YAML, and then my cron job.yaml. Let's see that everything is correct. So we have everything here. Let's put never. And actually we can, in this spec, what we are going to do is beam. Let me see, where was that? I want to hear, well, doesn't matter. Let's select from here. We had completions, we'll put 1, and then parallelism, we don't need, or we can put 3, 2. And then let's put again the backoff limit to something high. Backoff limit, we can put 20 again. Very good, KTL, get jobs. See, now we have now one running. And we can get the pods. Let's put it like this, watch, and let's see if another one will be created. But in any case, you see that that is actually running. I just put the cron job to start immediately. So now you can see the 3 levels. Get cron jobs, UCTL, get jobs. You can see this cron job, and you have one active job, which is this one, which has like 0 out of 2 completions. And you can get the 3rd level with pod. So now you see the 3 levels, right? The cron job that has that runs a job. Now there is one active, but it could be that if the job didn't complete on time, it could be that you have some jobs overlapping each other. But in this case, we have only one, that run here. This is your job. And actually, you can see that the jobs are getting a suffix, a random suffix with the name of the cron job. And then again, the pods get an extra suffix with the name of the job. So 3 levels, cron job, schedule at a certain time, job that is running because of the cron job in this case. And now we have several pods running because of the job. Oh, look, we have 2 completions now. So if you see the job, now is completed. And now because it completed, it's running another job again, right? And if we get the cron jobs, let me see. We have two jobs in this case now. So that's basically it, I think. Any other questions, guys, before we finish? Okay, cool. Okay, then thank you everyone for being here. Next week we have the 7th session about resource limits and service accounts. And I hope I'll see you there. Thank you everyone for being here.